So we saw what is zone-based firewall in the previous class, and then in this video, in this class, we are going to do lab on zone-based firewall. Here you see I have three zones. One is inside, can also be called as LAN. Another one is DMZ, demilitarized zone, and there are two outside. I can say out one and out two. Then totally we have four zones now. Out one and out two. This is a wonderful feature, you see, zone-based firewall. We create zones and we put the interface as a member of a zone. And if you wish to allow the traffic from R1, which is ISP1, to use your router and go to ISP2, then you need to apply a policy to allow it. By default, traffic from outside 1 will not be allowed to pass through outside 2. It's a very good feature. No one will like ISP1 using your router to go to ISP2. And this is achieved, through zone-based firewall. You need to simply put this interface in two different zones, period, boom. Right, whenever you want this inside to talk to ISP1, pair these two zones. And you want to also inside to talk to ISP2, pair the zones. So whichever is the best, it will pick automatically because you have access to both the ISPs from inside. But ISP to ISP, no traffic can pass through your router. The resources are not going to be spoiled. Anyway, these are the policies that we are going to have. Traffic from LAN, that is inside, is allowed to go to WAN, meaning ISP1 and ISP2, but only for HTTP and HTTPS. So we'll write an access list, we'll match 80 and 443. We'll bind the policy to the zone pair of zones, LAN and WAN. Next, traffic from LAN is allowed to DMZ unrestricted, meaning any traffic, any to any, you need a permit and attach the policy between the zone pair, which is LAN and DMZ. Traffic from DMZ is not allowed to LAN. Traffic that is originated from inside to LAN, inside to DMZ is allowed to go back to inside, means the reply is allowed from DMZ, but DMZ cannot be an initiator, cannot initiate a traffic, cannot be a source. DMZ cannot send a request. DMZ can only send a reply, whereas inside can send any traffic to DMZ and DMZ will receive it and respond also. But traffic originating from DMZ to inside is not permitted. It's the third policy. Traffic from DMZ is not allowed to LAN. But the traffic that is going as a reply from DMZ to inside is allowed. Because the second line says traffic from LAN is allowed to DMZ unrestricted. No restriction. Next, the fourth policy. The traffic from DMZ is allowed to go to WAN, but only for these two services, DNS and HTTP. So you need to say UDP 53 and then the HTTP, TCP 80. Next is WAN is allowed to LAN, but only for FTP servers. So 2021, we need to write policy from WAN to LAN. Yeah, LAN to WAN, you have both HTTP and HTTPS, but WAN to LAN, see the first one is LAN to WAN, HTTP and HTTPS, whereas the last one is WAN to LAN, which is only FTP. So direction matters. If the direction is from WAN to the inside, it's only FTP. If the direction is from LAN to the WAN, then it is both HTTP and HTTPS. Can you understand these 5 requirements?
Yes, Jay.
Now we need to create 4 policies. Sorry, 4 zones inside DMZ and ISP, outside and outside 1 and outside 2. Let's go and create. The zones need to be created on router 3. But before all this, we need to provide IP address to this topology. We need to have reachability between these devices. The routing is needed. So let us let's have some network for testing. On ISP1, I have 1.1.1.1, 32. Okay, ISP2 will also have 1.1.1.1. Let's take a different number for testing. So DMZ, we got a computer, we need to give IP address to this computer. I'm going to name the IP address as 192.168.0.2/24. And then yeah, this. I cannot duplicate its name. I'll give an IP address here 92.168.0.24. This is on DMZ interface. Right on serial 0 and outside I'm going to have a public IP address, let's say 11.11.11.1.3/24, which is on fast Ethernet. And then 11 instead of 11 is 12. 12.12.12.3 is on the outside. Outer. This will have 2. This is going to have 1. And now on the inside, I'm going to have a private IP, let's say 10.10.0.0.3. One. Okay, let me start configuring this PC first. For this PC, IP address is 10.0.0.1/24. The gateway is 10.0.0.3. See, IP address, mask, and gateway is assigned. Now, moving on to the computer here. IP is 192.168.0.2. Gateway is 192.168.0.1. All right, so then next. The pieces are ready now. Let's go to router 1, the ISP. Interface loopback 0, IP address is 1.1.1.1. Interface F0/0. And we're going to run OSPF. No. Let us do static routing here. IP route, I'll say I'm plugging default route. I'll say the only connected router is router 3. So I'll say go to 11.11.11.3. Similar configuration, we are going to do it on ISP2. Oof. Now, interface loopback 0 IP address is 2.2.2.2. Interface serial 6/0. And then again the default route IP route. Send the traffic to 12. Done. Okay, so ISPs are now configured, but we don't use any routing protocol to advertise the loopbacks. Not necessary because I'm going to write a static route on R3. Going to router 3. See, we are not doing any zone-based firewall configuration. We are just doing basic routing first. Interface G1/0, no SHAT, IP address is 10.003.255.255.255.0. Interface F0/0, no SHAT, IP address is 11.11.11.3. Interface serial 63/0, 12.12.12.3. Interface G2/0. And then we got, we need to write some static routes here. Yeah. What are they? This needs to know to reach the 222 network. So I'm saying IP route. If you're going to anything that starts with 2, go to 12.12.12 to mask. IP route, if you're going to 1, you need to go to so router 3 should be knowing routes to reach. We already gave the route. Now from here, if I ping, I will have reachability to 10.0.0.1, which is inside. I'll have reachability to DMZ. And I'll have ISP reachability. And I'll have reachability to another ISP also. So we are able to ping from here to anywhere. Not only that, If you now ping from inside to outside, you will have reachability. Means ISP1. And if you ping ISP2, you have reachability. And when you ping to DMZ, you have reachability. Not only that, from DMZ, if you try inside, you have no problem in reaching inside now. Not only that, if you ping ISP, you have no problem. And ISP2, no problem. Okay, so what is next? Next is from ISP we'll test. From ISP, if you ping inside, which is permitted. From ISP, if you ping DMZ, it's permitted. From ISP to another ISP, it's permitted. This shows that there is no security. Anyone can talk to anyone because the route is available. The router is going to route the packet. Okay. We provide security through firewall feature called zone-based firewall. For that, I need to put this interface in zones. Zone security, I'm going to say LAN for inside. Zone security, DMZ for DMZ. Zone security, out 1. Zone security, out. So we got zones created. Now I'm going to assign the interfaces to the zones. I go to G1/0 and say, oh, I made mistake. I am doing these things in router 1. Very funny. This has to be done where? In R3.
Router 3. Yeah.
Okay. Okay. So anyway, all operating system supports. I was doing in a service provider. See, show version. I was doing in a service provider version of operating system. The command was available. The command was okay. See, advanced IP service. Okay, so you need not to really have one security operating system to do this. Now I am going to R3 to configure zones. Zone security inside of LAN. Zone security outward. Zone security. Zone security. Show zone security. We have 4 zones created. Right, but no interface applied. Let's go now to interface G1 spreadsheet, zone member, security, LAN. Inside G2 0, zone member, security, DMZ. Interface F00, zone member, security, output. Interface serial 3/0, zone member, security. Now let's configure, verify show zone security. Now you can see zones and the member interface. Now if you try pinging, the ping will not happen. Earlier when I was pinging from inside, I was pinging everyone, but now I'm trying to ping DMZ, not going. It won't go. Because the firewall in the middle is not having policy to allow this. Ping ISP2, not allowed. You will not be able to ping from anywhere to anywhere. But we already know that the routes are available. We did not remove those routes. Still the routes are available. The policy doesn't allow. That's the problem. So not even ping anything. No protocol, no FTP, no HTTP, no HTTP. Everything is blocked. Okay. Now let us configure zone pair. If you want this to happen, the first one, traffic from LAN is allowed to WAN, meaning both ISP1 and ISP2. That's what WAN here means. But only for HTTP and HTTPS. Let's do one thing. For
Jay, one question here. So when we allow traffic from LAN to WAN, meaning LAN to out 1 and LAN to out 2, does it make router 1 and router 2 also communicate each other?
Not possible.
No, right? Not possible yet.
Not possible because we are pairing the zone separately. In LAN and ISP1, that is one pair, and LAN and ISP2, another pair. We are not pairing ISP
out 1 and out 2.
Out. Yeah. We are not pairing.
Okay, thank you.
Yeah. Now, this is what your first rule, policy, but today, these policies we'll do in our next class, but today, to make it simple, just to complete today's class, I'm going to make only ICMP.
Okay.
So we'll do this 5 policies in our next class. So now I'm going to go to router 3 and write a policy to allow the traffic. For that, I need to first do zone pair. Zone-pair. Security. And name of this zone pair, you give any name. I'm going to say in out 1 underscore ICMP. All right. And now, what is the source zone? From where to where? Direction is very important. LAN is a source zone. Source is LAN. And what is the destination zone? Is out 1. So zone pair is ready. Now inside the zone pair only, you need to call the policy, which we have not written so far. You see, you have a service policy. So we need to go and create that first. I'm going to exit from here. I'm going to say any traffic from inside to ISP, if it is ICMP permit. So IP access, or simply let's write numbered access list. Access list. Hey, no need. There is another way. Class map ICMP, match protocol ICMP. Okay. Come on, it takes so long. Come out. Okay. Now I'm going to say policy map ICMP -in -out one. Class is ICMP permit, or action should be permit, no drop. I don't want it to drop, I want it to forward. I think you don't need to take any action here. You need to just simply call the policy map under the zone pair. Now, I'm going back to the zone pair that which we created. And I say service policy. What's the policy map name? Policy map name is this.
ICMP.
Boom. Policy map. Sorry, service policy map type. Inspect. And the policy map name. That's it. But it does not exist. Show run section policy. Huh? UIL. It is there. Why does it say it doesn't exist? Then I need to write another policy map. Not this is layer 3 class policy map. I'll change this. Policy map type inspect. Here itself you have the name. And now I put this name. This is layer 7 class policy map. I'll teach these things later. Now we are going to say call the class ICMP. Class, okay, that is also need to be inspect. Okay, I need to change the class map also. I simply created a class map, a layer 3 class map called ICMP. I need to change it to class map type inspect ICMP, match protocol ICMP. And now I'll go under the policy map inspect ICMP, call the class ICMP. Now I'll go under, wait a minute, do I have any option here? Yeah, you see pass. Pass is the action. Allow, yeah? Pass. Now I'm going to bind this to that pair, zone pair. And here I'm going to say service policy type inspect. Because we put inspect here, we need to create the policy map also as type inspect.
Okay.
Class map also as type inspect. Okay, inspect. And the policy map name is this. This time it will accept. See, it has accepted. Now let us go and verify this. That's all. You will be able to ping now. But before that, I want to show you, show zone pair, show zone pair security. Oh, so we have a zone pair named in underscore out ICMP, which is allowing the traffic that is matching the service policy called ICMP in underscore out if the traffic is going between LAN to the destination out WAN. Okay, now let me show you the class map and policy map.
Jay,
Show.
one question. We did not mention direction in this policy map.
What?
So by default, it will take
No, 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 no,
bidirectional.
no, no, no. What? Source. Destination. Is it not a
Source
direction?
destination. Okay, okay. So it's only from LAN
LAN
to
to outside one.
LAN to outside. Okay, okay, got it. Sorry.
No problem. Show class map type inspect. See, we have a class map called blah blah ICMP matching this protocol and show policy map type inspect, and which is calling the ICMP and passing it. All the rest of the traffic should be dropped. Okay, now if I'll go to PC1, ping ICM, sorry, out1, which is R1, I will be pinging. Okay, come on, what happened? Okay, this is reply packet is blocked. You see, we have written only one direction.
Yeah.
Now I need to write another direction to allow the ICMP replies to come in. So how will you prove that it is really going? Go to R1 and enable debug. Debug IP ICMP. Now let's ping from here, and I'm expecting, look at this, packet is coming from 10001, that's why it is responding to 10001. Do you see that?
Yeah.
So
Yeah.
our policy is working, but because
Correct.
we don't have the return policy, you are not able to get the reply back. All right, for that you need to write another zone pair. We'll continue this in our next class. Right?